this all applies across the board. So whether you use Python, JavaScript, whichever, you can use all this kind of information for that. So, okay, so Docker at a high level primarily is about isolating processes. What you'll see mostly in Docker is things called containers, which are effectively lightweight VMs. And they're not true VMs, but for the sake of this context or a 101 into it, they are effectively a lightweight VM. Predominantly as a best practice, what you see with Docker containers is a single process container. So that could just be like a web server, and then there might be another container that has a database. So in a Rails app, you would have maybe you have background workers running. So you have Scikit running on one area, you have Nginx running somewhere else, you have Puma running as your app server, and then you have Redis running somewhere else, giving messages through IPC or something. That would end up being about 5 containers, each one being their own container. And the reason for this, though, is it's very much, if you're familiar with working with Heroku before, is you now kind of get in a situation where you can now scale based on each unit. So maybe you need more Redises to help your system. So now you can just scale that up. And if it fails, you can spin it up pretty quickly. The best thing that we've seen for it too, though, is it increases your application density on VMs. So you can run Linux on anything that has a Linux kernel above 310. So the most important thing to take note there is that when you spin up a VM, usually, when you spin up a VM, you're allocating system resources. So you have to say, I need 1 or 2 cores, I need this much RAM, and I need this much disk space for the VM. So you're pre-allocating that away, and now the machine no longer has that available to give to anybody else. The Docker way is using under the hood a Linux virtualization. So it allows it to go ahead and isolate the process, so it feels it's like in a jailed environment, similar to something in the past called jails. It was a successor to LXC. And with that, everything is more about like limits. So you have a limit of, say, computer shares, if you decide, or CPU shares, if you decide to limit that on containers. But also, same thing with memory. You can limit the memory if you want to, you don't have to. You can limit the space, but you don't have to. So the great thing about this, though, is you could spin up, say, 10 JavaScript applications, and instead of spinning up 10 VMs with each one having just a single JavaScript app, now you can go ahead and use your complete resources for the machine in a more effective way. So right now, what you've seen in the past is kind of like a move to like service-oriented architectures, microservices. Docker provides a really nice framework to set that up.
Hey, Richard.
Yep.
Could you just take a minute, and for those of us who don't know what Docker is already, could you just give us a brief explanation of what Docker is used for?
Yes, of course. Yes, yeah. So Docker at its base level is a way to containerize. I'm going to use the same word to define it.
Thank you. If you think about it, it's just a VM for a process.
A lightweight VM for a process is the best way to think about it. And predominantly what it is, though, is the greatest thing about it is that you can run it wherever you have Docker running. So essentially, like right now, when you have like test servers, or you have staging servers, or you have QA servers, before those servers had to be set up somehow, like they had to be configured, and there's kind of like a mess with versions. And so like when you're setting up Docker, each and every container and application is its own system. So you get like your own file system. You have multiple Linux stacks that you have to manage. You have multiple networking layers you have to manage. So with Docker, it handles all the networking for you in a nice, easy configuration file, and then you've got all your services laid out too. So yeah. So I mean, so imagine if you were looking at it from the perspective that you would have an entire VM dedicated to one piece of your application. Specifically saying, like in a Rails world, just Puma, right? This Puma is just being an app server. And now you've isolated that now from, say, its Redis or from its background workers. So what Docker is providing, though, is a platform so where you can, a consistent workflow where you can isolate processes and then run them effectively anywhere Docker can run. And we'll kind of dig deeper into what that means and how that becomes like a big factor in why you'd want to use Docker and why it's important. But at the high level, think of it like a lightweight VM is the best way to kind of think about it.
How would you compare it with what's come like before? For those of us in Windows, we would create a VM, right, with let's say the Oracle thing. And now with the new Windows 10 Anniversary Edition, it comes with a subsystem. So basically now we don't have to spin up VMs on Windows. We can use our bash and do all that with a Linux subsystem. It's not so much of like a full container like you're saying, but it's also you have everything in a subsystem. Is that closed? But
it's very close, but the thing to really, I don't know enough about the Windows side of the house, but the best way to say it though is provided that when the isolation happens, that process essentially can't see anything else. The best way to term it is like, you know, when you spin up a VM on your machine, that doesn't really have access to anything at the host. It doesn't, unless you give it access, it doesn't know about its file system above it. It just thinks it's a brand new machine. And for all intents and purposes, it is, right?
Okay, I see.
So that's the way to look at this. It's about isolation, and then you get security at that level, and then you get the networking set up. So very much like how you used VirtualBox or hypervisor or anything like that in the past before, this is just a lot more lightweight. And so what we'll show, I probably should have been on this page actually, is kind of that difference though. So on a traditional VM, you have a hypervisor, and you have to take the guest OS with you everywhere, right? Like you have to essentially install CentOS, or you have to install Ubuntu at a low level, and it comes with a lot of weight essentially. And really all you're trying to do is run one specific app or one library, and very similar to like you just mentioned about kind of isolating processes. As long as it does that, then it's close to what containers are. My understanding is that there's actually like, I've actually met people on the Docker core team that are on from Microsoft's from the Microsoft side. My understanding is that Docker is supposed to be included in 2017 for Windows Server 2017, is my understanding. So, because right now Docker is very Linux oriented, and when they say that you can run Docker on Azure, they're really just talking about running Docker inside of a Linux VM over there. But they are trying to make Docker native into Windows for the Windows Server. So yeah, so this is like the big difference here though. So you can get so the traditional VMs, you're talking about, you know, gigabytes and a ton of, you know, RAM isolated out. And on the right side with containers, what you're doing is you're essentially sharing the kernel, a common kernel across all your applications. What that provides is you not having to bring all the heavy weight of the OS, and it kind of removes you away from the need of kind of doing these monolithic apps. Like currently on the left on a traditional VM and a Rails app, you might decide like, oh, I'm just going to host everything on a VM. I'm going to put my Rails app, my app server. I'm going to put my background workers. I'm going to put my, you know, message queue, and you're also going to put in, you know, whatever other things, your, you know, reverse proxy or what have you. And then you then throw that VM up there. And you might decide, okay, well, I want to have infrastructure as code. So then you kind of get into Vagrant or Chef or Ansible or Salt. And then at some point you realize like you're just essentially just writing shell scripts at the end of the day, and that's all they're kind of facilitating. But it's not providing a very easy way for the person who's making it to deploy it, scale it up, bring it down. And then you're still going to have some problems likely between the people that are executing on those servers and on production versus the people that are doing on development. So containers provide a very isolated way, which all they're including at this point is just the apps and the binaries and libraries. Does that provide a clearer picture, or am I still? I mean, I need to make sure everybody understands it a little bit. Is there any other questions currently?
I think we're good.
Cool. Awesome. So this kind of highlights what I'm referring to with when it goes to file system layers with Docker. You essentially have like a base kernel that everybody's talking to, right? And then every container essentially starts where kind of like how the darker blue is, where it has Debian base image. So you start off with a very minimal OS, like, you know, the OSs are anywhere from like 400 to, or I'm sorry, as low as like 50 MB or even maybe less than that. I think it's like 5.
Is 5 meg.
Yeah, 5 meg, I think, with Alpine, all the way up to like a full Ubuntu, which is like, I think 600, 800 or something like that, maybe a little bit less. And then what you start doing though is there's a process called copy on write. And so what ends up happening is every time you add a new, you execute a new change to that image, there's a new layer added. And you can kind of think of it like if you were to apply Git. Everybody's familiar with Git, right, for this reference?
Yes.
Okay, great, awesome. So if you thought of Git as far as source code went, like Docker could be in a weird way Git for like OS. So it keeps track of what's happening. So you have a base image and it's like, okay, I have this base. Okay, you've added this change. We've added Emacs. Okay, great. I'm going to save that now too. Oh, you've added Apache. Okay, we're going to have that at the top. And it keeps the deltas between those images. And now anybody can kind of like clone from those those images and add whatever they want on top of that. So it just keeps referencing its previous image, very much like how Git works. So this is a standard workflow. It's pretty simple. Again, we're going to show you some of this later on in a live demo. I just wanted to kind of present all the content up front so we can kind of talk about it. So you start off with what's called a base, and I'm calling it a base image, and that could be like I said, as simple as an Ubuntu image, or something even smaller like what they call an Alpine distro. So any kind of like Linux flavor that you prefer, you start off there, or you can pick something higher. Like for instance, what we'll show later is somebody picking a Ruby or a Rails image, which means that somebody in the Ruby community grabbed like an Ubuntu underlying image and then added everything to build Ruby from source. And then once that was all compiled, they pushed that code or that image, that binary, up to the cloud, and now you can download that and work from that and have that as your base, and you can add whatever you want on top of that, with knowing that Ruby, whatever version, is always going to run from that image. So once you download that or use that, you can go ahead and from there write your code locally, do whatever you need to do, and then you'll essentially package that, and then you'll deploy that, and it can run anywhere Docker can. And we'll go through that. I know it's kind of quick. It says write code, package, deploy, but we'll kind of show exactly what that means and how files change and how things are mounted and unmounted, and kind of talk through some of that, so you guys can understand what's happening along each leg of the way. So I keep talking about Docker images. The main areas to get Docker images are from Docker Hub. So if you just type like Docker Hub into Google, you'll immediately hit it. And it's the main resource where everybody puts images. And the reason why you want to use this is because they have official Docker images, and those are mostly from the maintainers of the actual libraries. So for instance, the Ruby one is maintained by the Ruby community, the Rails one being maintained by the Rails community. And everybody that's using Docker and say Ruby or Rails grabs that original or that official image first, unless you have something specific, like you have a very resource constrained system and you need to build it from scratch, that's fine. Otherwise, grabbing the official images from Docker Hub is probably the most preferred way to do this. There is something of note though. Go ahead, you have something, Josh?
I just want to say that they just released it they announced it in the Docker Conf this year, that there's like a Docker store. So it's going to be actually more proprietary, not non-open source Docker images hosted that you can actually purchase, like maybe a full licensed SQL server, or Oracle might have their own Docker image there as well. So,
oh, interesting. I didn't even know that. That's cool. Another thing to note on that is, I don't know if anybody does anything with ARM or with Pies or with Qboxes or anything that's kind of like ARM based. Majority of Docker files currently are x86, x64 based. So just kind of have that as a note. If you're going to run anything on ARM, you're going to need a different base image than what you see around there. And mostly all the other images out there reference at a lower level the x86 images. So you'd have to build everything kind of from scratch. I don't know if anybody's using ARM, but in case you kind of find yourself in that scenario, just kind of a heads up. It's kind of a pain. Docker and ARM is not where it really needs to be right now. But based on talking to people from Docker, they say they're kind of like on their path to do that. If you decide, hey, I don't want to do Docker Hub, I don't want to push my code up there. It's it's public. And again, Docker Hub very much works like how GitHub works, where it has pricing for private Docker image hosting. So you can push images up there and keep them private so nobody else knows them. So like for your team or whichever. And that's great for a lot of people, but a lot of people need to have that behind, say, their own like enterprise firewall. So that's where something like Docker Registry comes in play. And Docker Registry is effectively the open source version of Docker Hub. It's actually what Docker Hub runs behind them. I think it's actually called now Docker Distribution Registry. So for a self-hosted solution, you can use Docker Registry and just essentially spin up your own container with it, or if you want to spin up your own VM with it, you can do that too. Additionally, they provide a Docker Trusted Registry commercial offering for anybody that needs to have kind of like higher security in their Docker Registry, and they still need it behind their firewall. Alternatively, I don't know if anybody uses GitLab. I'm a huge fan of GitLab. If you use GitLab 8.8 or higher, you could actually use whether you use their website version, like their hosted version, or whether you use the self-hosted where you spin it up in your own system locally, you can actually use what they call the GitLab Container Registry. And with that, you're able to essentially have it already kind of spun up, set up for you, and now it's kind of tied in with your Git system or your Git server, as well as also being tied in if you use the rest of GitLab, kind of like with GitLab CI, CD. So now you can kind of have it all together. So kind of what you see as a trend now, and I don't think I've written this in a slide, but what you see as a trend is you're working on your code locally. You make an image, and then you're pushing it up. But when you push up your code to your Git server, the Git server then fires off a CI build. The CI build then produces an image as an artifact, and then that artifact is then tested. The artifact being a Docker image, and then from there you can actually then release that to production. So that's kind of a chain that you see all the time. So if you have a CI pipeline in your current setup, what you'll find is Docker may be really helpful to kind of help expedite along the way. So to get up and running, we'll demonstrate using Docker for Mac, kind of give a quick little overview of it. Right now is a really good time to get into Docker if you've never got into Docker, primarily because it's way easier than it was, pre 1.0. Yeah. Back then it was kind of very painful, but it was still helpful for people that needed to build private clouds. But now it's been essentially after DockerCon a couple months ago, everything's gotten a lot easier. It seems like they've kind of gotten more people on their team to build what the industry kind of needs and what the community needs. So the two big ones, though, is they built native Docker clients for development. So Docker for Windows and Docker for Mac. Originally had this other thing called Bootsie Docker. Then they had this thing called Docker Toolbox, and it's always kind of a hodgepodge of stuff. And now these are the two recommended ways for doing development. Now, of course, if you're the kind of Linux user, then you can set it up separately. I'm not saying that of course, I mean, you have to run Docker on Linux, but the Docker is the Docker for Windows and Mac. Actually, my understanding is that they're both native clients. They just work in a very weird way, is my understanding. And then when you get to production, you have like two main options, right? Which is kind of like what you have all the time, which is you have a bare metal option. Which is you running your own Linux machines. Now, like there's some some providers that you can run, bare metal. So maybe you have your own infrastructure and you have a ton of machines and you want to cluster them together and you're maintaining your infrastructure locally. Or you're in a situation where you're like, hey, we use the cloud. So you might use Docker Cloud. or DigitalOcean or Azure. Along those lines, Google CE, AWS EC2, all those places, you'll essentially be running containers inside VMs. Some people argue against this, but for now, I think it's okay, and I don't think your performance hits are going to be super important. If you do need super important, there are some providers out there that run containers inside, like on the metal. One that I know of, just because they're based out of, that I know some friends at, is Joint. Joint runs containers on metal, I think using Open Solaris zones to run it. So on cloud providers, though, there are some that try and provide some easier way to utilize them. Like AWS has a thing called ECS, which is the Elastic Container Service. So you can deploy to there, and then it just kind of helps you configure everything. And then it just, charges you EC2 compute pricing. I believe Google on the GCE, they have the same kind of setup as well too. And then later on, you'll have a situation where you want to do orchestration amongst your VMs or amongst your infrastructure on the cloud. And mind you, I'm not talking about any passes right now or any services that just take your file and then post it up everywhere. A lot of I don't actually use any of them, so I don't actually know specifically which would be the best one to go to. So these cloud providers are more at the level of you building your own infrastructure on the cloud and then adding Docker to that and then running your system across that. Things to look up while you do that are things like Mesosphere, Kubernetes, but the latest version of Docker that we'll go over at the very end of this slide deck is Docker 1.12 or 1.12, which has a lot of orchestration built in, which could alleviate kind of some of the pains that were happening while you were trying to push to your own infrastructure in production. And we'll go over those later in this slide deck. So we're going to talk about the Dockerfile. So the Dockerfile is kind of like your first step into how to build an image. So it works very much like a shell script. We're gonna skip that version right now because we're in the middle of a demo about Docker. I don't know if anybody saw that, but that'd be great, right? I'll update that right now and fail this demo. Is everybody still there? Or is everybody just like sleeping? I assume everybody's sleeping right now, right? It was just like, oh man, this guy needs to shut up. We're here. Okay, awesome, great.
Just drinking beers.
Oh yeah, no, they should be. They're probably slamming beers back right now. Okay, so as you're building images, the main item that you start off with is the Dockerfile. So the Dockerfile works very much like a shell script. You have commands on each line, and each one is defining some execution of something to do, whether that's change the working directory, whether that's changing some ownership of a file, pretty much everything you kind of are used to in writing shell scripts. There's just a couple of like commands you have to add at the beginning of each line to do those specific things. But this is kind of where you define your dependencies. And if we think about it, imagine if you're writing an app and you just needed the dependencies specific to your application. So say you're using Nginx and you realize, well, I don't need the rest of my application. I just need, to install Nginx and I'm done and configure, the proxy settings and I'm good to go. And that's all you need to do. And we'll go over Dockerfiles here shortly. But the cool thing that I like a lot about Dockerfiles is that you can chain them. So one can inherit from the other. And we'll show that here in a second. I assumed I would show that here in a second. There we go. Okay. Okay. So inheriting from Dockerfiles. Okay. Yeah. Right. Okay. Sorry. Okay. So this is simply how you would build a Rails app. It's not a very complex thing. What it does is it grabs from another image called Rails. And there's a tag, that's where so Rails : and then tag. So it's image name and then tag. And what that does is it tells it tells the Docker client to pull from Docker Hub a Rails image that has a tag called OnBuild. Specifically in this scenario, you don't really need to know what OnBuild does, but to let you know, all it does is look at your gem file and then inject it into the image and then run it against run it against the container, and then save it. And we'll show that here in a second. Okay, so that OnBuild process that you saw right there, so that yellow, that from Rails OnBuild, right? And you can see the run at the bottom, which says, you know, your kind of basic stuff when you're doing kind of like assets precompile and stuff. That's going to inherit from the next file I'm going to show. So this file is what the Rails OnBuild process does. So this also inherits from another image or another Docker file called Ruby:22. So this is a little bit older one. So what that's doing though is grabbing a Docker Hub image from Ruby, or Docker Hub image that's Ruby with a tag of 2.2. Now, as you can probably imagine, what that means is you're going to start off with a base of Ruby 2.2. And then you get to run whatever you want to run after that, knowing that you have Ruby ready to go. And then from here, all you're doing is pretty much everything you would do to kind of set up an app. You're copying, and again, you have to be mindful that right now I'm going to walk through each one of these lines here. We don't have to really worry about line 4. That's more of a thing that it has to do so that it can be a little bit faster. But line 6, I don't know if you guys can see that. So run, make directory, user source app. So what we're doing there is we're making a directory inside of the container, right? And to understand this, right, images are the best way to be defined as like your class, if you will. If you think about like OOP, it's like your class, and then containers become like your objects, your instantiations of the image. So an image is essentially like a saved snapshot, and then containers are essentially instantiations of whatever that snapshot last was. So each one of these, we're going to essentially build a new image layer, and then we'll then execute based on the last one that we have. So in line 6, it's called run make dir user source app. What that's doing is it's saying, hey, we want to make a directory inside of this image. So inside of it, it'll run, make a new app, and now the image is done and it's executed and it's saved a new image layer. And now we're going to say, okay, well, we want to change the working directory context. So we change that to where it's at in the container. And again, just imagine like you're inside a Linux shell in this image, right? Inside of like if you were in a VM, right? You're making a new directory and you need to change that directory to then run your other items. And then from here, what we're saying is we want to copy from on lines 9 through 11, or 9 and 10, we're essentially copying 2 files to that directory. On line 11, where we say OnBuild run bundle install, everybody knows what that does. And then after we install everything, line 13 says to copy everything inside our folder. So this would be all your application code, and then we're copying it into the app code. The reason you don't want to do a bundle install before you copy your code is that every time you change your code, you no longer you change your gems less than you change your code. So there's kind of like, this is kind of a trick where you essentially only have to install, you only do the bundle install once, because Docker will cache all lines of execution unless they've changed. So if your gem file changes, then it'll essentially go back to line 9 and re-execute everything again. Now, the difference is if you only change code, it only has to go back and rebuild after 13, unless you do host mounting or host volumes or do a data container, which we won't go into right now. And then lines 15 and 16 are essentially to get Rails installed. So you're installing Node, and you're installing a MySQL client, a Postgres client, SQL client, and then farther in there is a Rails install. And then 18 and 19 are about exposing the ports. So again, just like a VM, you have to expose some ports to say, hey, this VM needs to be able to talk, on some port on the host machine. So in this case, if you were running, say, Dockers for Mac, your host machine will look at this container and say, okay, he's exposed at 3000, and now I can go ahead and talk to him on port 3000. And line 19 is the final command you would run inside of a Linux machine to spin up a Rails server. Does that make sense to anybody right now? Or, I mean, it'll make sense when we kind of go over this in code as well, too.
Yes.
Yeah, thank you. Yes.
Somebody else.
Yes, yes. If you haven't seen this, it's a little bit daunting at first. So, but in code, it'll be a little bit easier to kind of discuss it. So what'll end up I don't know if you can see this. The point is not, you don't really have to see all the code inside here. It's not really, I mean, these are all more configuration files rather than something actually happened. Docker is really more about just configuration execution rather than, you know, touching anything in your code or anything. So every app you have probably isn't just one process running. So that's where things like Docker Compose come into play, where you use, it's a tool to essentially do multi-container management. So you're effectively needing to, so like when you come up to your system and you say, okay, I need a web app, I need a database, I need Redis, I need a worker running. At that point, you have a specific now configuration. You have all these kind of processes kind of do an interplay between each other. And you kind of need to orchestrate that and set, or not orchestrate, but set those pieces up. And they need to be aware of each other, right? Like, so like the web service needs to be aware of the database service in order to save stuff, right? It needs to be aware of Redis in order to communicate through there and save, maybe it's like cache. And likewise with the worker, with Sidekick, it needs Redis in order to store the job first before it fires it off. So Docker Compose provides a way to do that, and we'll kind of give an example of Docker Compose in our demo here shortly. Okay, and then lastly, we're just going to talk really quickly about some of the features in 1.12, which there's 4 things that they kind of talked about. We kind of saw this at DockerCon this year, and of course, you can look this online, and it talks more in detail. But there was a big push for security, pretty much security by default. And so now you'll have essentially TLS security on by default, and they'll have like a rotating key setup where I think you can have it as low as like every 30 minutes, the rotating keys. And when you set up the initial system, I think it sets it up with where internally you're your own certificate authority. And then you can add external certificate authorities if you want to. There's more resiliency, so they're definitely pushing to make orchestration better. Over the past couple of years, there's been a lot of orchestration tools to come out to try and help do multi-host, multi-container. Some people here in this room may have situations where they have a ton of applications across a ton of data centers or a ton of machines, and they need to run across all those machines, and they all need to be able to talk to each other and understand each other. And if one fails, the whole system needs to be aware, and they need to talk to each other. So they implemented something called a RAF consensus, where everybody talks to each other to ensure that there's no single point of failure, and that they can each pick up the slack for each other. Inside of Docker 1.12, they made orchestration easier. So they kind of took some of the stuff that I think we saw with like with other tools in the ecosystem, and they made what Docker's native orchestration client called Swarm. They kind of like upgraded him, and it made it easier for doing multi-host, multi-container setups. They're also introducing something called a DAB file. If I was on video, I would do a DAB, but I can't because I'm showing this. It's a distributed application bundle, and so essentially what it does is it's a one file deployment. So everyone here that has a Rails app, like I said, will have like multiple containers, multiple services. You can just distribute this one application, and you say, hey, this is how it talks to each other, this is how it works, and then the Docker will figure out how to deploy it to your cluster of hosts. Again, I say cluster of hosts and things like that. You may only have a single host. You may just be running one small VM or one small machine. It doesn't matter. It's in whatever context you need it to be.